So that was making pancakes. What about making molecules? Same idea, exact same idea. Our balanced chemical equation is the recipe. So here, we're not making pancakes, we're making ammonia molecules. And the recipe is 3 hydrogen molecules plus 1 nitrogen molecule will make 2 ammonia molecules. Okay? So this is true on the particle level, looking at individual molecules, but do we ever do anything on that small of a scale? No, because these are things that are so small that even with a great microscope we can't see them. We do these on larger scales. It's not even just a dozen, right? It's a mole. The chemist doesn't. So when we look at this equation, we can interpret it this way in terms of number of molecules, or we can insert mole. So this is 1 mole, and this would be 2 moles. So we can say that 3 moles of hydrogen particles, which is something that's large enough that we could actually weigh it, reacts with 1 mole of nitrogen molecules to make 2 moles of ammonia. So we don't put the unit into the equation, but it's just like taking something and multiplying everything by 5 or multiplying everything by 12 and calling it a dozen. We're just multiplying everything by Avogadro's number and calling it a mole. It's just a larger amount that's more useful to us. So we can get relationships between the quantities of these molecules, and we call those mole ratios. So 3 moles of hydrogen is equal to how many moles of ammonia? 2. Because the equation tells us 3 quantities, whatever quantity you want, 3 quantities of hydrogen will get you 2 quantities of ammonia. So we can write that mole ratio. How about the relationship between hydrogen and nitrogen? 3 moles of hydrogen need how many moles of nitrogen? 1. 1 mole of nitrogen. How about 1 mole of nitrogen would get us how many moles of ammonia? 2. That's not hard, right? It's just the numbers here. Now there's, we don't write 1, so you have to remember, oh yeah, there's a 1 there. 3 moles of this to 1 mole of that. 1 mole of this to 2 moles of that. 2 moles of this to 3 moles of that. You can take any 2 reactants and or products and get the relationship from the balanced chemical equation. Everybody okay with that? You see how I'm doing that? Not like voodoo or anything. So if we have 3 moles of nitrogen and plenty of hydrogen, how much ammonia can we make? This is just like the eggs and pancake question, except it's with weird things. So 3 moles of nitrogen, and we want to know how many moles of ammonia. Well, dimensional analysis says multiply by the unit that you want, divide by the unit that you've got, that you want to get rid of. So I want to divide by moles of nitrogen so they go away. I'm multiplying by moles of ammonia because that's what the question is asking me. Put your units in place. Then look at the balanced chemical equation and get the relationship. 2 moles of ammonia for every 1 mole of nitrogen. So 2 moles of ammonia to 1 mole of nitrogen. So we do the math, 3 times 2 divided by 1, and we get 6. 6 moles of ammonia. Is that good? Let's do this one. Now this one doesn't have whole numbers. How many moles of nitrogen are needed to completely react with 7.13 moles of hydrogen? Well, we're starting with 7.13 moles of hydrogen. And the question is how many moles of nitrogen? So I want to multiply by moles of nitrogen and divide by moles of hydrogen. So the units work out. The relationship between these moles comes from the balanced chemical equation. For every 3 moles of hydrogen, I need 1 mole of nitrogen. So 1 mole of nitrogen, 3 moles of hydrogen. Now that requires a calculator. 7.13 divided by 3. So 2.3, I'm going to round that off to 3 sig figs moles of nitrogen. I'm using 3 because of this. These numbers are exact. These coefficients in the balanced chemical equation are exact numbers because 3 molecules of hydrogen would be a counting number. 3 molecules react with 1 molecule to form 2 molecules. And when we say mole, we're just expanding the number of them, but those are still considered exact numbers. So you're going to be limited by the number that you're given, the 7.13 moles. Any questions?